So welcome everybody to this latest video on 162 Maths, and in this video we're doing an AQA GCSE Maths higher topic test around rounding. Now as always there'll be a copy of the test paper that we go through in this video for you to download and have an attempt at either before watching this video or while watching this video by simply clicking on the link in the description below. Now before we start working through this test paper, it's worth mentioning that there is no indication about whether these questions are calculator or non-calculator. So the approach that we will take is that each of the questions are non-calculator unless a question involves some quite complex or time-consuming calculations, in where we will use our calculator just to save a bit of time. So looking at question 1, it says the attendance at a football match is 30,400 to 3 significant figures. Circle the minimum possible attendance. So for this, let's have a look at what these is going to, the upper limits and lower limits is going to be. Now 3 sig fig represents the 4 and that represents 100. So this number has been rounded to the nearest 100. And 30,400 nearest 100 is going to be, the upper limit is going to be 30350. And 30450. So the minimum possible attendance is going to be this second option. Now for 1b, it says circle the maximum possible attendance. Well, for this, again, when you're looking at the upper and lower limits, it can't actually equal the maximum limit. It's always going to be that little bit less than that. Now, because obviously only whole numbers can attend a football match, you can't have like 0.3 of a person, so therefore the maximum possible attendance is going to be 30,449. Because again, just to go over, in terms of the attendance, it can equal the lower limit, but it can't equal the upper limit. Moving on to question 2, it says that a bag of sugar has a mass of 500 grams to the nearest 10 grams. Work out the upper bound of the mass of 4 of these bags. So let's first of all look at the limits are going to be. So the limits are going to be to the nearest 10 gram. So that's going to be plus 500 plus or minus 5. So that's going to be 495 and 505. Now the upper bound is going to be that number. So it's going to be 505 multiplied by 4, and that gives me an answer of 2020. Moving on to question 3, it says that a piece of wood measures 0.45 meters to 2 decimal places. Use inequalities to write down the error interval of the length due to rounding. So for this, to second decimal place, that's going to be 0.01. So if we divide that by 2, I get 0.005. So then I've got 0.45 plus or minus 0.005. And so therefore the lower limit is going to be 0.0445. And if we just use X as our letter, now you could use any letter you want, and the upper limit is going to be 0.455. Moving on to question 4, it says 2 performances of a show are each attended by 175 people to the nearest 5. Work out the maximum possible difference between the numbers of people attending. So for this, to the nearest 5, we're looking at 172.5 to 177.5. Now obviously when we're dealing with people, we can't have, let's say, a decimal person. So we'll call this 173 and we'll call this 177. Now the reason why I've rounded up and down is because I want whole numbers that satisfy these two limits here. So I'm looking for whole numbers that are between those two green numbers. Now the maximum possible difference, so the maximum difference is going to be the biggest minus the smallest. So the biggest attendance I can have is 177 and the smallest is going to be 173. So the answer therefore is going to be 4. Moving on to question 5, it says the number of students in a year is 250 to 2 sig fig and 200 to 1 sig fig. How many students could there be? Give all possible answers. So for 2 sig fig, this is going to be rounded to the nearest 10. So that's going to be 245 to 255. And for 1 sig fig, that's going to be to the nearest 100. So that's going to be 150 to 250. So what whole numbers can definitely fulfill this? Now, really what we should be doing is writing these as inequalities. So let's just do just that. So we've got n, and that's going to be 2, 5, 5. And then we've got n, and we've got 250. So what I'm looking for are numbers that satisfy both of these two inequalities. So a number has got to be between 150 and 250, inclusive of 150, and it's got to be between 245 and 255, inclusive of 245. So here, the numbers I'm looking for are going to be these two. So I want whole numbers that are between 245 and 250, inclusive of 245. So the numbers that could it possibly be is 245, 246, 247, 248, and 249. Because obviously it can't be 250 because then that falls under the upper limit of the second specification. So moving on to question 6, it says that Mo says that he is 24 years old. Use inequalities to write down the error interval of his age due to truncating. Now, this is a really important word that we need to establish because it's not going to be normal upper and lower bounds. Now, with truncating, what you need to do in terms of this new form of rounding, it's about ignoring all the decimal points that follow it. So there's no looking at the digit next to it and seeing if it's greater than 4 to then increase 1 to the numbers before it. It's just a case of basically just deleting a load of numbers. So for this, what it's going to be is that the smallest number that Mo can be is 24, and the largest it's going to be is a number that is less than 25. So for this, because obviously then if we had 24.9 and we truncated that, then basically to the nearest whole number we basically get rid of the 9 and it's still 24, even if it's 24.9997. If we wanted to truncate to the nearest year, because we're doing it to whole numbers, we ignore any of those. So there is going to be our error interval. Moving on to question 7, it says that a carton of cream contains 150 milliliters to the nearest milliliter. Emma assumes the measurement is exact. She needs 150 milliliters of cream. Work out the maximum possible error, percentage error due to her assumption. So for this, to the nearest milliliter is going to be 149.5. I'll just call it C, and the upper limit is going to be 150.5. Now, in terms of working out the percentage error, there are two ways in which we can do this. So the maximum error is either going to be 150 using the upper limit minus what she's assuming, which is 150, over what she assumed, and we multiply that by 100. Or alternately, what we could do is do 150 minus the lower limit over 150 multiplied by 100. Now, both of those are going to give you 0.5 over 150 times 100, which simplified gives you 0.33. Now, although the answer looks very, very similar, you might be tempted to think, oh, that's 33%. The reason why it's not is because we're already multiplied by 100, which therefore means that our answer is the percentage and we don't need to convert that decimal into the percentage. Moving on to question 8, it says the tallest person in a room is 195.6 centimeters. The smallest person is 150.2. Both measurements are given to one decimal place. Work out the maximum possible difference of their height. So looking at this, let's just do the upper and lower limits. So that's going to be to the nearest one decimal place, so it's nearest tenth of a centimeter. So that's going to be 195.6 plus and minus, and that's going to be 0.05. And the same with this one, it's going to be 150.2 plus or minus 0.05. Now if I do those, what do I get? Well, I'm going to get 195.55 and 195.65, and for this one I'm going to get 150.15 and 150.25. Now it's really important you do show those upper and lower limits, and then to get the maximum difference, which is a maximum substitution, I want big minus the small, So I want the biggest tall person, which is 195.65, and I want the smallest of the smallest limit of the smaller person. So that's going to be 150.15, and that gives me an answer of 45.5. Then moving on to our last question, it says that a container holds 12 litres of bubble bath to the nearest litre. It is used to completely fill bottles that hold 0.25 litres each to 2 decimal places. Work out how many bottles can definitely be completely filled. You must show you're working out. So for this, let's have a look at the upper and lower limits. So for the container, the upper and lower limits, well, to the nearest litre is going to be 11.5 to 12.5. And for the bottles, it's going to be the lower limit, which is going to be 0.245 and 0.255. Now, for it to be definitely completely filled, we want the worst case scenario. So what we're wanting is the smallest possible container with the largest bottle. So what we're wanting is the smallest container divided by the largest bottle. So to do that, the smallest possible container is going to be 11.5 divided by 0.255. And again, I'll probably assume this is going to be on a calculator paper, and you should get an answer of 45.